Here are some examples from the day 57 assignment. Here we'll be finding volume, and here they want us to find the volume of this looks like a triangular prism. The bases are triangles. So the formula for the volume of a triangular prism is the volume is the base times the height of the triangle times the height of the prism and then divided by 2. So all I need to do is substitute. The base of the triangle that I'll be using is the 9 yards. The height that meets it at 90 degrees is 18 yards. And then the distance from one triangle to the other is 15, and that would be then divided by 2. Just some quick mental math. I know that I can knock these out. That becomes 9. So then 9 times 9 times 15 is 1215. 1,215 cubic yards. Okay, find the volume of the prism. The area of the pentagonal base is 126 divided by 1036 square meters. Its height is 14. If necessary, round to the nearest hundredth. Okay, so we know that generically speaking, that the volume of any prism is the area of the base times the height. So since they give us the entire area of the base already, we can just say this is 126 over 1036, and then times the height, which is 14. I'll just use the calculator for this since we're going to have to round anyway. So 126 divided by tangent of 36 is around 173, and then divide that by 14. So to the nearest hundredth, I'm getting approximately 12.39. Round to the nearest hundredth. Did I put that right? Oh, I put divided by. Sorry about that. That makes no sense. I should have put times. So should have gotten 2427.94. 2427. So let's try that number there. Let's try 2427.94. All right. Find the volume of this prism. If necessary, round to the nearest hundred. So this looks to be an oblique rectangular prism, but even though it's oblique, they do give us the length, the width, and the height. Notice how the height is meeting at 90 degrees. So all I have to do is multiply these three numbers. So 6 times 9 times 5. I know 6 times 5 is 30. 30 times 9 is 270. So we have 270 cubic centimeters. Find the volume of the composite figure round to the nearest tenth. The volume of the composite figure is, okay, so these might be a little hard to see, but this is a bigger cylinder that looks like it's had another cylinder hollowed out of it. The other cylinder has been taken out of it. So the way that we can find this composite figure is through subtraction. So I'm going to have the volume of a big cylinder minus the volume of the smaller cylinder. So the volume of a cylinder is pi r squared times the height. So pi times on the big cylinder, it's the radius is 10 squared times the height, which is 14. But then minus pi, and then the radius of the smaller one is 5 squared. But the height is the same. The height is also 14, and we'll subtract. So this gives me 100 pi times 14, which is going to be 1400 pi, minus 25 times 14, which is 350 pi. 1400 minus 350 is 1050. So we have 1050 pi on most tests and quizzes that I give you. This is the number I would want. But here in the book, they want you to round to the nearest tenth. So I'll put that in the calculator, 1050 times my pi button. So that would give me 3298.7. 3298.7. Okay, find the volume of this composite figure. So this looks to be a rectangular prism here in the middle, but then I'm adding half of a cylinder, and then I'm adding another half of a cylinder. And since those cylinders have the same radius and the same height, I can just treat it as one cylinder. So I'm going to do volume of a rectangular prism plus volume of just one cylinder, because half and half is one. So the volume of a rectangular prism is length times width times height. Those dimensions appear to be 6, 4, and 13. So 6 times 4 times 13, plus the cylinder, which would be pi r, the radius is 3, squared times the height, and that height going up and down is 4. So the volume is 6 times 4 times 13. That gives me 312, plus 9 times 4 is 36 pi. If this were a test or a quiz, this would be the end. You would have to stop here because these two cannot be added. And if I ask it for you exact, just leave it like that, 312 plus 36 pi. But they do want you to round here to the nearest 10. So 312 plus 36 pi to the nearest 10 is going to be 425.1. 425.1. Okay, Abigail has a cylindrical candle mold with the dimensions shown. If Abigail has a rectangular block of wax measuring 14 by 12 by 17, how many candles can she make after melting the block of wax? Round to the nearest tenth. So what we would want to do here is first find the volume of that block of wax that she has to work with, which is 4 by 12 by 17, to figure out how much wax she has. So that's going to be 14 times 12 times 17. That gives me 2,856 cubic centimeters. And then I would figure out what the volume of the candle is, which if it's a cylinder, that's going to be pi r squared times the height. So pi times 3.5 squared times the height, which is 6. And then if I want to see how many candles, how about how many candles can she make? Then I would divide. So let's see, 3.5 squared times 6 is 73.5 pi. So if I have 2856 cubic centimeters to work with, divided by 73.5 pi for each candle, 2856 divided by 73.5 pi, that gives me about 12.36 candles. So they wanted us to round to the nearest tenth, but that 0.36 is not enough of a candle. So this is a weird question here. So I would say she can make 12 candles because if they wanted us to round to the nearest tenth, 0.36 rounds to zero point 0.4. So zero point 0.4 of a candle would not be an entire candle. Let's see. There you go.